Stuart again with another 12-factor video. This time we tackle configuration. So here's what 12-factor net says about it in gruesome detail. Store configuration in the environment. And we're going to talk a lot more about that. Basically, it's configuration if it changes by environment. Or it could be changed at runtime to change the behavior of your application. That being said, we have a complaint. And the complaint is that the major programming platforms make it way too easy to put configuration in files. And the problem with that is twofold. First, things like secrets don't belong in source control. And neither, frankly, do things like SQL Server connection strings and the URLs to services. These things should be discovered at runtime. And the second problem is that if you mess up your file-based configuration, you could deploy the wrong configuration to the wrong environment, and that might have disastrous effects. For example, deploying the production environment to UAT. People are doing their testing and so on, unaware that they're changing data in production. Now, obviously, we can prevent this critical OWASP top 10 security vulnerability by some networking magic, but that's not always possible, and it certainly isn't sufficient. Here's how configuration should be visualized, and the size of the block is roughly proportional to the size of the stuff that you typically put in it. And the idea is that there are some things that you want to have vary in your code, but you don't want to hard code them as constants in the code itself. And one of the acceptable things to put in there is the self-identity of the thing that you intend to deploy. So, for example, for functions and APIs and things, you might want to put the name of the thing that you want passed to service discovery, which is a different video, so that when other people ask for that same name, they get the URL to your function or service. All well and good, but this should be a very slim list of things. The other thing that's acceptable is sensible defaults. So if I deploy to an environment and for whatever reason the logging isn't configured, the static files would provide some sensible defaults. It should not include things that vary by environment ever. So again, connection strings, very bad. Secrets, very bad. Credentials, incredibly bad. So the next tier of configuration up is environment variables. And typically, these are injected via the CD pipeline or are part of the hosting configuration. And they typically don't include things that are secret, but they include things that are useful. For example, CD pipelines often inject as part of their deployment an environment variable that might have the DNS name of your configuration or secret server. There's no harm in not being known if somebody compromises the host. It's not a secret, but it is useful. Other things that hosts inject frequently are things like logging configuration and information about the host itself. What kind of operating system, how much memory, how many CPUs, any special features, that sort of thing. And that can be useful information for your configuration to know. For example, if you have an error page where you are writing error messages to a log, it's nice to enrich those logs with as much host information as possible. And particularly if you have your application deployed across a whole bunch of hosts, the identity and information of the specific host that failed you is a useful thing to put into the logs. So again, things that are not super secret, but very useful. And again, this is almost purely reserved for infrastructural and deployment type items. The 80% use case for your configuration that varies by environment should be in configuration server. And a good configuration server has two easy security principles. The first is that the data is encrypted at rest and at motion. And the second is that you can only write or read configuration if you have the appropriate authentication and authorization. How this is done varies by configuration server. And lastly, there are cases where we need a higher level of security than configuration servers can provide, or there is a specific set of, for example, authentication or cryptography keys or whatever that the secret server manages and rotates and so on. And so when your application needs a secret, it would ask the secret server and be assured that it would get the right one for not only the application, but the environment and, of course, the required permission levels. Here's the flow of what an ideal build and deployment looks like through the lens of configuration. We're going to ignore a bunch of other stuff about building and deploying. Those are going to be in a different video. But I wanted to hit on the configuration items. Notice that we have 4 purple configuration streams, the same that were in the layer cake in the previous slide. And so let's just start and go left to right, up and around. I start with source code and I do a CI build, and the output of the CI build goes into the artifact repository. Why? Because the rubric is we build once and deploy many times. See our video on number 1, code base. And then as things need to be deployed, the deployment engine plucks your now ready, packaged, and deployable application from the artifact repository, and along with the static files that were in source control, it injects certain environment variables. Again, typically things like the DNS addresses for well-known things like configuration server, service discovery, etc. for your environment. And then as your code is deployed to the host, it's deploying onto an existing host, right? So our infrastructure deployment process will have created the infrastructure. And when it did that, it too injected environment variables into the application host. And the point is that the app instance can read the static files and the union of environment variables from the CD process and the IC process. And they typically don't overlap. In fact, we should take pains to make sure they don't. I'll point out that for some application hosts, it's possible to change the environment variables at runtime. And that makes things like logging levels excellent things to put in environment variables because they can be tweaked from the outside. So when your application instance starts on the application host, it reads the static files and environment variables in which, hopefully, it has gotten the information it requires to find the configuration server and then the secret server and complete its configuration. The last step your application instance should always do is validate the configuration in some way. Do you have all the keys in your now union configuration dictionary that you require? Are the values appropriate? That is to say, not empty, are they of the right type? Are they numbers, booleans, URLs, whatever? And if humanly possible, if it's possible for things that represent backing services, again, a different video, if you can do a liveliness or connectedness check to that, that wouldn't be the worst thing in the world. Obviously, you want to do that in your health check endpoint anyway. So many application teams say, no, the application endpoint will check for that. And if we detect something truly awful, it'll fail the health check, and then we'll know what's going on. I'll point out that there are different ways of configuration server and secret services. And in some cases, as in my HashiCorp Vault demo, I actually use HashiCorp Vault to be both my configuration server and secret server, because it transpires that Vault offers me in one place the level of security I want, not only for managing the key value pairs in the configuration dictionary by environment, by application, but it also provides the required functionality to do key rotations and other kinds of cryptographic things, and to manage authorization and authentication metadata that I would use against the appropriate services. So in some circumstances, you can combine those. In others, it may be desirable to keep those things separate. And the care and feeding of those secrets and that configuration is an out-of-band process, typically managed through the same sort of process that you would go through for any infrastructure change, which is some sort of ticketing and accountability. We like to see configuration and secret services, for example, keep a journal of changes and who changed them and when. So if we have configuration problems, we can debug that. And many mature configuration services allow you to compare the configuration keys across environments and tell you, for example, if in dev you've added 3 new configuration keys, but they have yet to be propagated to the next environment, aha, red flag, and we can do something about that. That's configuration 12-factor style in a nutshell. This is an introduction, and there's a ton of detail that goes with it.